Hey Algebra 1 students, today's lesson is going to just be an overview of Chapter 8. We're going to actually hit a couple of different sections. We're going to just talk about graphing quadratic functions. We've mentioned a couple times this year, they graph what we call a parabola, which is a U-shape, and we're going to graph with a table. You might want to have a calculator handy to go through this lesson. We're going to start out on page 247 of your journal, and we're going to talk about some of the characteristics of a quadratic. So first of all, this U shape that you see here is called a parabola. Okay, parabola can either have a low point if it opens up, we'd say this parabola opens up, or it can have a high point if it opens down like that. That lower high point is called the vertex, and it is just a point, so maybe it would be up here at the top. Okay, and your vertex can either be a maximum, this vertex right here is the maximum, it's the highest point, or your vertex can be a minimum. Besides the vertex, a parabola also has a line of symmetry known as the axis of symmetry. The axis of symmetry goes right down through the middle of the parabola. Okay, it would be if I folded the parabola on that line, it would match up, unless it's my hand-drawn one right there. Okay, so we have the vertex, we have the axis of symmetry, we can know whether it opens up or down. We're going to investigate the opening up or down a little more on the next slide. We're going to keep this video pretty simple on graphing parabolas, and I just want to touch on one thing, but I do want you to know, and we're going to come back and visit this later, that there are many different transformations that you can use in order to graph a parabola. You can use shrinks and stretches, translations, shifting left, right, up, down. You can use reflections, but right now the main thing that we're going to touch on is just if your leading coefficient, remember your leading coefficient is what's out front, if your leading coefficient is greater than 0, and another way of saying greater than 0 would be to say that it is positive, then your parabola is going to open up, okay? And on the other hand, if your leading coefficient, that number out front, if your leading coefficient is negative, those are your numbers that are less than 0. If your leading coefficient is negative, your parabola is going to open down. And we're just going to touch on that here because that is the easiest thing for you to double check to make sure you might have graphed your parabola correctly. Does it correctly open up or down? Okay, so it all is based on the leading coefficient. Leading coefficient that is positive will open upwards. Okay, and a leading coefficient that's negative will open down. All right, we are on page 248 of your journal, and we're just going to identify the characteristics about these two graphs. So for characteristics, one of them can just be which way does it open. So for number 1, does that open up or down? We're going to say that it opens up. And what about number 2? Does it open up or down? Okay, we're going to say it opens down. Then remember that we can talk about the vertex, and the vertex is a point. So it's the turning point is what it is. So for number 1, the vertex has what ordered pair? Should be -1, 1 is what it looks like to me. And for number 2 over here, the vertex has what ordered pair? It looks to be 3, 4. Now, not necessarily asking, but I'm going to put this in here now, is that for number 1, this vertex is considered a minimum because that's the lowest point, so I'm just going to add to that. This is a minimum. And for number 2, this vertex is a maximum. All right, the last thing we're going to look at is the axis of symmetry. So remember, the axis of symmetry is a line that goes through the vertex. And if you folded on that line, your parabola would line up. Now, it's been a while since we talked about horizontal and vertical lines, but when your line is either horizontal or vertical, your equation is either x equals or y equals. and it all depends on the points. So if we actually come in here and we look at some of these points, this top point here is -1, 7. The next point is -1, 6. The next point here would be -1, 5, -1, 4. And you will notice they all have a -1 for the x, and that is actually your equation. Your axis of symmetry, I'm going to abbreviate AOS here. Your axis of symmetry is x equals -1. You have to have that x equals part because it's an equation. So you can't just put -1, you have to put x equals -1. But if you look at your ordered pairs, all of your x's were -1. So if we look over at number 2, and we look at some of the ordered pairs, this is 3, 0, 3, -1, 3, -2, 3, -3, 3, -4. What do they all have in common? Their x is 3. So your axis of symmetry over here is x equals 3. And the axis of symmetry can be really helpful when graphing. We're not going to use it as much today, but we'll have another video later on about axis of symmetry. All right, so on page 249 of your journal, we're going to start out by graphing, okay? And the way that you are always going to graph is you are going to make a table, okay? So our table looks like this. We have our x's and our y's, and you are just going to basically randomly select x's, plug them into your equation, see what you get for y. You're going to make ordered pairs, and you're going to graph them. So for example, let's say my first x is 0. If I put 0 in right here, following your order of operations, so you're going to square first. 0 squared is 0 times 5, still 0. Then maybe I put in 1. So put in 1 for this x. 1 squared is 1 times 5 is 5. Okay? Can't forget about negatives, so let me do -1. When you put -1 in for this x, okay, that is -1 squared. If you're doing that in your calculator, that has to look like that. When you square -1, -1 times -1 is a +1, and your answer then is 5. And then let's go ahead and put in 2. 2 squared is 4, times 5 is 20. And if I do -2, -2 squared is also 4, times 5 is 20. So if I want to graph this, maybe I put my y-axis in the middle, and I put my x-axis about here. Actually, let's put our x-axis on the bottom. And then I think we can count by, if this is like 2, 4, 6, 8, 12, 14, 16, 18, yep, 20 is at the top. On your x-axis, I'm only going to count by 1s. So then when you graph your points, I'm going to graph 0, 0. 1, 5 would be about here. -1, 5. 2, 20. -2, 20. Okay, and do you see that U shape in there? We're going to draw that. See if you can make it not as pointed there on the bottom. And you do need to put arrows on it. All right. Hey, using the exact same x's we used, I want you to make the table for number 4. All you need to do, like pause it, make your table, and then come back and I'll finish graphing it with you. All right, hopefully you got this table. Okay, notice that all of our y values are negative. So this time when we draw in our axes, we're going to keep the y-axis in the middle there, but I'm actually going to put my x-axis now at the top. We're going to keep counting our x-axis by 1s. But now we're going to count our y-axis by -2s. Up to -20 there. Okay, so if you graph those, we got 0, 0, 1, -4, -1, -4, and then 2, -16, and negative 2, negative 16. And when you draw this one, it now opens down. And remember what I said earlier, it's going to open down because your leading coefficient right here is negative. And over here, this one opened up because your leading coefficient was positive. All right, we're going to actually move on to the next section. Find page 253 in your journal. If you want to read through this section, you can learn about how this plus and minus at the end actually moves your parabola up. That's going to move it up 5, and that's going to move it down 3. Those are really helpful things when graphing. I'm not going to take the time right now, though, to go through all those because I just want you to have a general understanding of how to graph. So we're going to stick with making a table. I'm going to make a table. And in fact, right now, it is okay to stick with 0, 1, negative 1, 2, and negative 2. So if I put in those numbers, if I put in 0, 0 squared is 0, plus 5 is 5. If I put in 1, 1 squared is 1, plus 5 is 6. Negative 1 squared is 1, plus 5 is also 6. 2 squared is 4, plus 5 is 9. And negative 2 squared is 4, plus 5 is 9. Okay, so I need to graph this. I'm going to keep my x-axis on the bottom, y-axis in the middle, and this time I'm just going to count by 1, so I'm actually not going to write in what I'm counting by. So we got 0, 5, puts it right there. Let me try again here. 0, 5, 1, 6, negative 1, 6, and 2, 9, and negative 2, 9. And again, do you see that U shape in there? We got both sides. It's symmetric. There we go. Okay, why don't you pause and see if you can do number 2? All right, in case you haven't finished this one, I went ahead and put the x-axis about the middle. So I can graph. I have 0, negative 3, which is down here, 1, negative 2, negative 1, negative 2, and 2, 1, and negative 2, 1. So that when I draw on my parabola, that's what I get. All right, we're going to move on to the next section now. All right, find page 259 in your journal. So you'll notice these are much more involved equations. I got a lot going on here, and you're going to keep the same method. You're just going to make a table. Now I'm going to tell you though, 0, 1, negative 1, 2, and negative 2 are not always going to work. You're just going to have to use some numbers, see what you get. Okay, this is where a calculator can come in handy, especially a calculator where you can go back and change your entry so you don't have to type it all in again. So I'm going to still start with 0. I'm going to put 0 in for both of these x's. So 0 squared is 0, times 3 is 0, 0 times 6 is 0, so you're going to get 2. And that's one of the points. All right, because I've worked ahead a little bit, I know that we can graph this one kind of in the middle. So I'm going to go ahead and draw these in. But in general, you might want to come up with a couple of points first. So I know I have a point at 0, 2. Okay, you don't know that's the vertex. Okay, do not assume that's the vertex. So find another point. So let's plug in 1. Okay, 1 squared is 1, times 3 is 3. 6 times 1 is 6, so we're up to 9, 10, 11. So at 1, we are at 11. Now, that's just right off. Well, that's going to be more than right off. All right, maybe we're up here someplace. We'll just put a point up there. Okay, so probably if I go to 2, I'm just going to get a bigger number. So I'm actually going to go back and go to negative 1. Do not assume it's 11. So I'm plugging in negative 1 for both x's. Negative 1 squared is 1, times 3 is 3, so this one is 3, but the next one is actually a negative 6, right? Because you have positive 6 times a negative 1. Add those together, what are we at? Negative 1. So at negative 1, we're at negative 1. So that wasn't symmetric, right? Here to there, not symmetric because that's not the vertex. Do not assume that's the vertex. Okay, let's keep coming this way. I don't know what happens. So I can kind of see a curve, but I don't know what's going to happen over here. So we're going to go to -2. Let's see if I can reuse this down here. So if I change these to be -2's, okay, -2 squared is 4. Times 3 is 12, but this is -12 plus 2, so that looks to be 2. You got a calculator, make sure you can do these in your calculator. So at -2, we're at 2. All right, so do you see where those two now match and we have this going on? Okay. Tell you what, I will let you stop right there. Usually I make them do more. The next one is actually going to be 11. You're going to be back up here, and you're going to have something that looks like that. Okay. So what I want you to do is I want you to pause. I want you to see if you can make the table for number 6. Start with 0 and then kind of see where you go from there. All right, I didn't graph it yet, but hopefully you got some of these points on your table. Okay. And these are easier to graph when you could just have a whole sheet grid paper and you can make your coordinate plane as big as you want it. But since we are trying to use what is given to us here, I'm actually going to draw my x-axis right here at the top, y-axis, wherever we want, maybe there. Okay. If I start plotting points, I have 0, -1, 1, -7, should be there, 2, -9, 3, -7, 4, -1. And do you see how we have enough points in there that we can see where that's headed? All right. The other thing, just to reiterate one more time, notice both of these parabolas open up because both of them have positive leading coefficients. All right. This is just an overview of graphing parabolas. You're going to make a table. Okay, have a calculator handy to help you. Let me know if you have any questions. Have a good day.